All right, so let's work on some of these problems. All right, so just kind of like a recap of what we've been doing thus far. So if you have a problem like this, I to the 34, remember you take the 34, divide it by 4, which gives you approximately 8.5. Now we're not worried about anything. Sorry about that, forgot to turn off my phone. Not really worried about this 8. We're just more concerned with this point 0.5 business. So the point 0.5 business, if you remember our little circle or cycle from 1.3. Oh, there it is. So we had 4 possible answers, right? We had either it was going to be this as our answer, this as our answer, this as our answer, or 1. And I told you that just kind of remember that just it's a 4 uh, piece cycle, so just 0.25, 0.50, 0.25, and 1. So our answer right here was 0.50. So our answer is going to be -1. So let's come back over here. Whoa, did I hit the wrong one? Yep. So it would be I squared, which means -1. Okay. Right here, we're just foiling. So 2 times 4 is 8. 2 times 5i is 10i. -3i times 4 is -12i. -3i times 5i would give us a -15i squared. We combine like terms right here. This becomes 2i minus 15i squared. This should send out a little red flag. That's a flag, by the way. Red flag. Because I squared is actually just -1, right? So we could make this -1, which gives us 8 minus 2i plus 15. Add these two up, and we get our answer of 23 minus 2i. Okay. Right here, we're going to solve for x. How do I get rid of a square? I take the square root. So now we have x minus 5 equals the square root of 64. But remember, you always, whenever you take the square root, you have a plus and a minus answer. So we're going to have x minus 5 can either be positive 8, comma, or -8, okay? Because we could have a plus or minus. So now how do we continue to solve for x? We add 5, but now since we have two answers, we have to add 5 to both of these. These cancel, and we get x equals to 13 and x equals to -3. All right, so I think I caught a little mistake right here. Change this to an 11. I think that should be 11. Okay, so right here we're going to factor. And what we're going to do is we're going to find two numbers that multiply to 18 that add up to -11. So two numbers that multiply to positive 18 would be x minus 9 um, and x minus 2, right? So -9 times -2 gives us -18. You add these two up, it gives you -11. So please fix that. Sorry about that. Over here, again, we're solving for x, so we're going to subtract 4 to both sides first. And then we get 8. Now here, it's a square root, so we're going to square it. So we get x plus 11 equals 64, because now the square root is canceled by the square. And then we subtract 11, and we get x equals 253. Midpoint, if you guys don't remember, midpoint is you get your two x's, you add them up, divide by 2. So -8 plus 3 gives us -5 over 2. And then you're going to do kind of the same process, but with the y's. So you're going to get -8 plus 4 and divided by 2. So this becomes -4 divided by 2, which this can get reduced. So we're going to be left with -5 over 2 and -2. Okay. Now on this one, this is one that actually um, this one right here, number 7, this is one that I feel like a lot of people were having a little bit of trouble. I know I got a couple of questions on this one as far as what to do. Um, they couldn't find the radius or they couldn't find the center. So, like I said, to find the center, we have to do the midpoint. So this is a circle, right? So we have a circle right here. I'm just going to kind of draw it real quick, freehand, not too big. You guys don't have to applaud or anything like that. Nah. So we have -5, -6. Now, this is not drawn to scale, right? So -3 and 1. So these are the endpoints. Now, the halfway marker would be our center. Okay, so we want to find the midpoint. The midpoint will give us the center. So we're going to go 3 plus a -5, and we're going to divide by 2. And we're going to go 1 plus a -6, and we're going to divide by 2. So this gives us -2 over 2. This gives us -5 over 2, which gives us -1 over -5 over 2. Okay, so that's our center. Okay. Now, once we do that, our radius is from one of the endpoints to the center. That's our radius. And to figure that out, we need to use the distance formula. So now I'm going to use the distance formula for r, which would be, whoops, I forgot the plus. Which is x2 minus x1 squared plus y2 minus y1. Okay, so again, I am going to use one of the center and the endpoint. All right, so I'm going to make this my x2 and y2 right here. And then this would be my x1, y1. So I'm going to have x2, which is -1, minus my x1, which is 3, plus my y2, which is -5 over 2, minus my y1, which is 1. Okay, this just becomes a -4 squared, and this becomes like say -5 over 2 minus 2 over 2, which would give us -7 over 2. Okay, now to square it, this becomes 16. This becomes 49 over 4. And again, this is all under square root, and square root. 49. So let me put that in the calculator. 49 over 4 plus 16 would give us 113 over 4. And that is our radius. Okay. So then all we need is our center. So we put minus 1 squared, and then minus 5 over 2 squared equals to this r squared. Remember, it's always squared. So this would be right here. So let me just kind of erase that. So it'd be this squared. So now we could simplify. This becomes x plus 1 squared, y plus 5 over 2 squared. And then the square root and the square cancel, leaving us 113 over 4. Okay. This one, again, this is a little one of those uh, problems that I was kind of just giving you guys a peek into calculus, but I really want to get into the lesson right now. So I'll leave this for bonus points. If you guys do it, you get 5 bonus points. Okay. But I want to see all the steps. All right. So this is just kind of warm up. Just kind of just breaks it down of everything we've done so far. So now let's do composite functions. Okay. So what is a composite function? So a composite function kind of feeds into something that we've already done, kind of like substitution. So like if I was to tell you that x is just really 3c, what I would do is I would want you to plug in 3c for every x that you see. So f of 3c would look like this. So we would put 3c squared plus 2 times 3c minus 3, which 3 squared is 9, c squared is just c squared, 2 times 3 is 6, and so f of 3c is that, right? So it's just kind of like substituting, right? Where they're telling us what to put in for x. So we're going to compose functions within other functions. So like right here, if they tell you what is fc, okay, so that means we're pretty much just changing all of the x's to c's, which is easy, nice and not so much work. But now we have this 5 on the outside. So that means what happens is I am multiplying my entire function by 5. So I'm going to take everything I have and I'm going to multiply by 5. So my function is going to change. So 5 times c squared is 5c squared. 5 times 2 is 10c. And 5 times negative 3 is negative 15. And there you have it. Now here's where it gets a little tricky. So the problems, these little basic steps they're not so bad. They're not so difficult to understand. But what's going to happen on your homework is they're going to give you something like this. And the reason why I wanted to show you guys this is because if you notice, I chunked it one piece at a time. So they're going to tell you what is f of 3c minus f of 5 f of c, and they give you this function. Well, we just did that. Okay, we just did that. We already know what f of 3c is. It's right here. So this is just 9c squared minus 6c minus 3. Now we're going to have a minus, okay? And I'm going to put parentheses because now I'm going to put everything I know for f of f 5 f of c. Sorry about that. So now I have 5 c squared plus 10c minus 15. So what happens here is I just kind of flip the sign. So this positive becomes a negative, this positive becomes a negative, and this negative becomes a positive. And now all I have to do is combine like terms. So 9c squared minus 5c squared gives us 4c squared. Negative 6c minus 10c is negative 16c. Negative 3 plus 15 would give us 12. And that is our answer. Okay. So it's just kind of inputting something for C and then just kind of messing around with it. So they're going to ask you to do all these little changes to the function by inputting something for X, right? Now, every now and then they're going to give you something simple, something like this, where they actually give you a number, right? So they're going to give you a function of F, right? And they're going to ask you plug in 2, right? So right here, I'm just going to go 2 squared plus 1. 2 squared is 4 plus 1. 4 plus 1 is 5. And then they're going to give you a different equation, right? A g function. And you're also going to plug in 2. So we're going to have 3 times 2 plus 5. 3 times 2, 6. 6 plus 5 is 11. And notice there's a plus sign in between. So then our final step would to add these two. So it's good to always chunk the work, okay? Always chunk the work. Do one bit and piece at a time. Okay. So these are a couple of function rules that you could possibly have. Um, so when we're doing composite functions, you're always going to have kind of like two equations, and you're either going to add them together, subtract them together, multiply them together, divide them together. So let's kind of get these together. So like, let's say we're going to add f of x plus g of x. Okay, I'm going to do this in purple. So f of x is just x squared minus 1 plus my g of x, which is x plus 1. So we combine like terms, and in this case, we can just, there's no x squared, so we'll just leave x squared like that. X is by itself. And then pretty much just negative 1 plus 1, they cancel, and that is our answer. So it's not too tough, not too tough, not too tough. But when we get to subtraction, it gets a little different, right? So we have x squared minus 1, f of x. But now we have a minus. So whenever you have a minus, you have to put parentheses around the entire thing. So now I'm going to change the entire, uh, the entire values on the inside. So this positive x becomes negative, this positive 1 becomes negative. And now I'm going to have x squared minus x minus 2. And that is my answer. Okay. So adding, subtracting. Now, of course, this is probably something that you guys are accustomed to, and that is foiling, right? So the next one would be, what would you do when you had to multiply them together, right? So this is something that we do often, right? We've been doing this process steps when we're doing complex numbers. So we're going to have x squared times x, which is x to the third, x squared times 1, x squared, and then right here, negative 1 times x is negative x. Negative 1 times positive 1 is just negative 1. And we have our answer. Okay. Um, the next one's a little bit difficult, right? We have f of x, which is right here, x squared minus 1, divided by x plus 1. Now, I don't know if you guys noticed, but this x squared minus 1 is a special trinomial. It's a difference of squares. We kind of talked about this a while back. Or no, I think I talked about it in the last lecture video, right? So this actually gets expanded to x plus 1 and x minus 1. And it's really neat because now this and this cancel, leaving me just x minus 1. But you should look up your difference of difference of squares, trinomials. Trinomials. I'll give you guys a list. I'll try to find like the most common ones that pop up. It's usually like x squared minus 1, x squared minus let's see, 4, x squared minus 9, x squared minus 16, x squared minus 25, x squared minus 36, x squared minus 49, x squared minus 64, x squared minus 81, and then x squared minus 100. These are like the most common ones that pop up, and these are difference of squares, right? Each one of these can be factored into the positive and negative set. I just realized I put both positives here. Give me a second. So it should be positive, negative. Um, And I think you guys kind of get the point. Okay. Now, composite functions, what we're going to now do is we're actually going to combine these two functions together. Now, you're probably thinking, sorry, we've been doing that. We combined them here. We combined them here, combined them here, combined. Well, yes and no. Now we're going to we're going to take a step further. We're going to embed one function into the other function. So what I'm going to do is we have f of x, which is x squared minus 1, and we have g of x, which is x plus 1. So what we're going to do is we're going to embed g of x inside the f of x. So we're going to take all of this and we're going to embed it there. So the way I like to do this is you get your outside letter. In this case, it's f. So you get your f function, and wherever you see the variable, you put parentheses. And then whatever's inside the right here, whatever they're telling you, in this case it's g, that function is what goes inside the parentheses. So in this case it'll be x plus 1. Okay, now we could expand this out, multiply it, all that good stuff, but for the most part I am worried about you guys getting the concept of embedding one entire equation inside the other. So I'm more worried about you guys knowing that than anything else. So I'm going to do a couple of examples. Let's see. Yeah. No. Yeah. So you guys can kind of see, and then we're going to go from there. All right. So let me zoom in a little bit. So right here, notice I have F on the outside. So what I'm going to do first is I am going to write out my F, and wherever I see an X, I am going to put parentheses. Now I notice my G's on the inside. So this is going to go on the inside of my parentheses. So 5x squared plus 3x. Now again, I could multiply this out, right? I could distribute this, and this will be 25x squared plus 15x plus 4, right? However, I'm not really worried about you doing the mathematical process of distribution or simplifying. My idea is I want us to be able to set up the equation, the function, the composite function correctly. All right. That's my main goal, right? So like right here, f. F is on the outside, so I'm writing this. So I'm gonna write parentheses to the power of 3. Now, what is inside the parentheses is g of x, so that means this goes inside right here, which would be x plus 1. Now, again, I could expand this out, multiply x. What I mean is, this is actually saying x plus 1 times x plus 1 times x plus 1, right? Because it's the power of 3. I can do it 3 times. But I don't want us to really focus on the actual distribution. I want us to be able to understand the concept of plugging one inside the other. Okay? So I'm hoping this is making sense. Now look at this one. This one, we're having two combinations. We're going to have the combination of f of g. Then we're going to have the combination of g of f. So we have two answers here. So let's start off with this one. F of g. So it says fog, right? Kind of looks like fog. So f first. So I'm gonna put parentheses divided by parentheses minus 2. And what's my second letter? Is my g. So my g is what goes inside. So I'm gonna put 5 over x and 5 over x. Okay. Again, I am not worried about simplifying. I am not worried about um, any other thing. Multiplication. Sorry about that. F of, let's take a look. G. Okay. Um, I just want you to get good at setting up. Now here on this one, we're kind of doing the opposite. We're starting with the G. So that means I'm going to have 5 divided by parentheses. Okay, and now my F, my F is what gets plugged in here. Okay, so then my F would be X over X minus 2. And this would be equal to G of F of X, which could also be written as G of F of X, like this. So these are just different notations of how to write it. Okay, the G is inside the F. And right here, the F is inside the G. So I don't want you to worry about, multiplying and simplifying. I just want you to do the setup correctly. All right? Do the setup correctly. So like let's do another example real quick. So let's say we had f of x equals to 3x plus 4 and g of x is 2x squared. Right? If I wanted f of g of x and I wanted g of f of x. So we're going to do both combinations. So like right here, I would first start off with my f. So I would write 3 parentheses plus 4. Inside this is my g, so inside goes my g. So 2x to the second. Okay. Now, of course, I could multiply this, I could simplify this, but I'm not worried about that right now. What I'm worried about is us getting this, the setup correctly. The multiplication, the division, the simplification. I know you guys are good at that. I'm not going to even worry about that. Okay. I want us to get the setup correctly. All right. Right here. Here, we're starting off with the G. So on this one, I'm going to write out my G, and wherever I see an X, I'm putting parentheses. Okay. Now, what's inside my parentheses is now my F. So now this F goes inside here. And again, we can multiply, distribute, all that good stuff, but I'm worried about the setup. Okay. So keep that in mind. A lot of the answers are going to look a little funky like this. Don't let it trip you out if it looks a little odd. Just kind of type it like that in the calculator. In the program, the computer. It should give you the answer. It should count it right. Okay, and if it doesn't, just send me an email, screenshot it, send me an email, and I'll try to fix it. Okay. Oh, right here. This is a good one. This is like a little puzzle. All right, so check this out. They tell you that h of x is f of g. And they tell you g is x plus 6. And they tell you that h of x is also 1 over x plus 6. So it's like a little puzzle. It's like a little puzzle. So we know f of g of x is equal to h of x, which is actually just 1 over x plus 6. Okay? And we know g of x is x plus 6. What would f of x be? So that means this x plus 6 is my g. So that's what I plugged in for x. So my f of x has to be just 1 over x. Because remember, the g's on the inside. So that means this x plus 6 will turn into an x. It's like a little puzzle. You will get like 2 of these on your homework. So far, so good. I hope so. Now, these are my all-time favorite way of doing composite functions because it involves 2 graphs. And it actually involves a little thinking. Okay? So On the equation part, building the equations, we started with the outside number and worked our way in. On the graph, I like to start with our inside number. So what is g of 1? All right, so g of 1. So that means this is f of x, so I'm not looking at this graph right now. I'm looking at the g graph. So I'm going to go g of 1. And my g of 1 would be 1, 2, 3, 4. So this is 1, comma 4. So my g of 1 is 4. So this g of 1 turns into a 4. So now this g1 that we now know is 4, we put it here. Now we come over here to the f side. Because the f side, now we have to figure out what is 4. 1, 2, 3, 4. Which is right here, 4, comma 0. And this would be our answer. So 4 of 0, f of 4, sorry, is 0. Okay, hopefully this is making sense. Number 2, right here, is f of 4. We just did that one. F of 4 is right here at 0. So that means we're going to have g of 0, which now g of 0 is right there, which is 0, 0. So g of 0 is 0. So this is answer is just 0. Answer is 0. Okay. Again, we're going to start off right here. G of 0. G of 0, we just figured it out, is is 0. So then now we're going to have f of 0. Well, what is f of 0? And we have this point right here, 0, comma 1. So that's 1. So like a little puzzle that you have to kind of be jumping back and forth. So we always start right here, this inside, g of 6. G of 6 is 1, 2, 3, 4, 5, 6, which would be this point right here. And that point is 6, comma 2. So that means we're going to have f of 2. So then we come over here to f of 2, which is 1, 2, 3, 4, 2, 4, which is just 4. Because f of 2 is 4. Okay. Start right here, f of negative 1. Wait a minute. Is there a negative 1? No, there is not. So this is no solution, right? Because there is no negative 1. So you can either put no solution or does not exist. So on your computer program, it's probably D and E. Does not exist. Okay. Now this is the one that always trips everybody up. F of an F. So we start off with F5, which is here, 5, 1, 2, 3, 4, 5. So F of 5 is 5, 5. So then that becomes 5 again, which is just 5. We just figured it out. Okay. So it's kind of like you're just kind of plugging in the number, the output for whatever X they're telling you. So this is the X, then this is the output. This now becomes the new X, and then that's the output. So it's kind of like a ping pong ball, right? So you're going from here to here, from here you get the answer, or vice versa. Okay. So right here, let's start off with the G of 3. So G of 3 is 1, 2, 3. 1, 2, 3, 4, 5. So it's this point. So 3, 5. So that means this becomes f of 5. F of 5 is right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So 5 over 6. So our answer would be 6. Okay. G of negative 1. Negative 1 is right here. So it's negative 1 comma 0. So then this G of negative 1 becomes a 0 because that negative 1 is 0. So then we come f of 0, which is 1, 2, 3, 4. And our answer is 4. Okay. Hopefully that wasn't too, too tough. If you guys have any questions, please feel free to